Okay, hello everyone. Welcome back to my channel. Yeah. So today I'm going to share some examples of how to find combined resistance of resistors in two kinds of circuit, series and parallel. Okay. So let's start. For this video, I'm using the Cloud Zoom meeting. Combined with Microsoft Word. So here I'm going to explain it to you all. So we have two useful equations that we can use. The first one is for series circuit. The second one is for parallel circuit. Okay. Now let's take a look at the example. Okay. So I'm going to have the drawing. I'm going to write down the answer directly below the problem. Okay, so for this case, right, how to find the R or the combined resistance, So just for the equation over here, R1 plus R2 plus R3. So here, I just write down 2 ohm plus 3 ohm and then plus 4 ohm. So I got the result is 9 ohm. Okay, simple, right? Yeah, I believe that it is easy for you. Okay, now for this one, for the second one, okay, maybe I need to rewrite the equations, because what is it? The equation is you cannot see it directly. Okay, so I'm going to rewrite it. So 1 per R equals 1 per R1 plus 1 per R2 plus 1 per R3. Okay. Okay, and here for number 1, number 2, it's clear that we need to find the combined resistance between point A and B. So this is point A, this is point B. Okay. Later in the next problem, you have you have four points unmistaken. Okay. So now let's get back to problem number 2. So in here, just put the value of the number. Okay. Like this. Okay. And then you do the fraction operation in mathematics. You make all the denominators equal. Okay. So in here, the denominators will be 12. Okay. Because it is the least common multiplication. Okay. So this one becomes times 6, right? So this is 6. This one times 4, so this becomes 1 times 4, and this one times 3 becomes 1 times 3, which is 3. Okay, so right over here, you get the answer is 1 per R equals 13 per 12. Okay, how to find the R? Because the one that is being asked is R, not 1 per R. Okay, so just inverse it like this. R per 1 will be equal to, you do the same on the right side. So it will come like this. Okay. So the result of the R is 12 over 13 ohm. Okay. Yeah, I think it's quite simple. And then look at number 3. Now, as I have told you before, we have 4 points. Over here you got A, B, C, and D. Okay. So if we want to find it one by one, but in the end, our target is to find the resistance between A and D. Okay, so let's make it step by step. So if you look at here, Between point and B is already clear, A and B only. Okay, so the resistance here is 1 ohm. Okay, and then for the B1, yeah. Okay, or maybe in order to get it clearer, I'm going to write them completely. Okay, so we can also write it on as RAB, which means that the resistance between A and B, so it's 1 ohm. Okay, and then for the B1, the resistance between point B and C. Okay, okay, and since we have two resistors over there, right, we need to use an equation. Yeah, and if as you can see here, we have parallel circuit again. So let's just put it like this: 1 per R equals 1 per 2 plus 1 per 3. Okay, so like the previous one, equalize the denominators. This is will be 6 and 6. Okay, so this 1 times 3, and this is 1 times 2. So you got 5 per 6. Okay, so if 1 per R is 5 out of 6, okay, so R per 1 is 6 out of 5, which is 1.2 ohm. Okay, so yeah, the R will be 1.2 ohm. Okay, for the B1. Now we talk about the C. Yeah, we need to find the R between point C and D. Okay, and it's clear enough in the picture, in the drawing, yeah, that the resistance is 4 ohm. Okay, so if you were to find the resistors between point A and D, which means it includes all the resistors, right? So just add them. So you got 1 ohm because they are in series, right? Plus 1.2 ohm plus 4 ohm. And you get the result 6.2 ohm. Okay. Now, as the last example, this time I will go directly. Yeah. So if you can see here, right, in the drawing, it is combination of series and parallel again. Okay. So let's start from the complicated one. Yeah, I think the most complicated one is the parallel one, this one. Okay, this one. Right. Okay. And then this is the parallel, but there is a series in a parallel. Yeah. Which one? This one is the series in the parallel. Okay. So what we have to do, yeah, you can remake, yeah, in order to understand it better, you can remake the circuit. You can redraw the circuit. For example, it will come like this. Okay. Yeah. So this one, 4 ohm and 4 ohm, yeah, on the top, right? In series, which means, yeah, if I combine them, they will be 8 ohm. Okay. The same, and this one is the same, 8 ohm. And this one is also the same, 4 ohm. While this one is 10 ohm. Okay. So, are they being simplified like that? Okay. Next. Wait. Okay. Yeah. Yeah. I think it's clear enough. Yeah. Next. How to And then to solve or to finish it, yeah, just do like the previous one. So we find the parallel one first. So R, we find the parallel first, the parallel, right? Find it first, right? So in here, I write down 1 per R will be equal to 1 per 8 plus 1 per 8 plus 1 per 4, right? Equalize the denominator again, don't forget. Okay, find the least common multiplication or multiple. So you got 8 over here, right? 1, 1, 2. Okay, so you got 4 out of 8, or for 1 per R, which means R per 1 equals 8 out of 4, which is 2. Wait. Okay, which is 2 ohm. Okay. So the total combined resistance will be R total. Okay, will be 2 ohm plus. Okay, this is the parallel one, and then look at here on the right side you got the 10 ohm. So just add it with 10 ohm because it is forming a series circuit. So the final result is 12 ohm. Okay. Yeah, I think that's all that I can share, yeah, about finding the combined resistance of resistors. Okay, I hope this can be useful for you. So if you like it, yeah, please like and subscribe. Thank you.